Unit 2, Lesson 5. So this is working with two equations for each relationship. So in Lesson 4, we kind of worked with how we can write an equation using the constant of proportionality. So Lesson 5 just jumps into that and looks at both equations for each relationship. So we're not going to worry about the warm-up today. So 5.2, meters and centimeters. So we know that there are 100 centimeters in every meter. Therefore, 0.94 meters is how many centimeters? Good. Okay, 1.67 meters is how many centimeters? What about 57.24 meters? How many centimeters would that be? (5,724 centimeters). Okay, so for any amount of meters that I give you, how would you determine the length in centimeters? Okay, so if you notice, I'm multiplying the left side by 100 to determine my length on the right side. So it would just be 100 times x. Okay, what about this table? So if you notice, our centimeters and meters switch sides. So if 100 centimeters is equal to 1 meter, so how many meters is equal to 250 centimeters? That would be 2.5. Okay, 78.2 centimeters. (0.782). Okay, 123.9 centimeters. (1.239 meters). So what are we doing now to determine our length in meters when we're given centimeters? Okay, so you're dividing by 100, whereas here we were multiplying by 100. But we say to always multiply instead of divide, so dividing by 100 is the same thing as multiplying by what? 1/100th. Let's see if I can doodle this. This is going to look terrible. Sorry guys, my iPad is, oh my goodness, is at school. So I'm making do with what I have. A little crooked, but that works. So on the left table, I'll multiply by 100. Well, since my labels switch sides, I need to use the reciprocal. And the reciprocal of 100 is 1/100. So I would multiply that times my length in centimeters to determine the number of meters. So 1/100th times y. 1/100th is also equal to 0.01 times y. Okay, so it says to find the constant of proportionality. So for table 1, what was my constant of proportionality? It was 100. Okay, what about for table 2? What was my constant of proportionality? 1/100th. You can use either form. Okay, so what's the relationship between the constant of proportionalities? The constant, I cannot type it out. So the constant of proportionalities are reciprocals. Okay, number 4. So it wants us to write an equation where x is equal to meters and y is centimeters. Okay, so for table 1, our equation would be y equals 100 times x. Okay, what about the second table? What would our equation be? So we switch sides. X is our meters, so it'd be x equals 1/100th times our centimeters. So if you wrote this as a fraction, it'd be 1/100th times y. So if you notice, when our labels switch side on the tables, our variables, the x and the y, also switch places, and our constant of proportionality, we just use the reciprocal. So there's the two equations for each relationship. So we know the relationship between meters and centimeters, or that 1 meter is 100 centimeters. So by writing these two equations, we can determine meters and centimeters regardless of the number that we're given. Okay, 5.3. So it says that it took Priya 5 minutes to fill a cooler with 8 gallons of water, and the faucet was flowing at a steady rate. So why is the steady rate important? Okay, because it lets us know that the water is coming out at a constant speed, which means it is proportional, that there will be a constant of proportionality. So if W represents the number of gallons in the cooler after T minutes, then which equations would represent the relationship between W and T? So W is our water, and T is our minutes. So I know that 5 is my minutes. So if I built a table over here, okay, I know that it's not perfect, but I know that my water and my minutes. So when I had 8 gallons of water, it took me 5 minutes. So if my water I know that I would need to do 5 divided by 8 in order to find my constant of proportionality. So 5 divided by 8 is 0.6. Shh, go. 0.625 times W. So this would mean that, I'm sorry, I put M for minutes instead of T. So this would be a T. Get out! I'm busy. all kinds of stuff on the video. Okay. Sorry for that interruption. So we have T here. Okay, so T equals 0.625 W. That is the correct one. And 0.625 is equal to, it's not a circle, 5/8. So that would be the same thing as writing T equals 5/8 times W. Okay, so what if we switch places with the T and the W? So if I want to know what W equals, I need to determine what my constant of proportionality would be. So I know it was 5 divided by 8 here, so I need to use the reciprocal. So would A or B be the correct answer for my second equation? Okay, it would be A. Because when T and W switch places, I would divide the opposite way. So it would be 8 divided by 5, which is equal to 1.6. Okay, so it says, what does 1.6 tell you about the situation? So we know it's a constant of proportionality, but what does the constant of proportionality of 1.6 mean for this situation? Okay, so we know that the 8 was our amount of gallons. So we know 5 was the number of minutes. So 1.6 tells us that the water is flowing at a rate of 1.6 gallons per minute. So since it was gallons divided by minutes, that means our answer was gallons per minute. So what does 0.625 tell you about the situation? So that tells you 0.625. Remember, we switched here. So it means it takes 0.625 minutes per gallon. So for each gallon of water that she fills in the cooler, it took 0.625 minutes to fill 1 gallon worth of water. So when your reciprocal, when your fraction switches, so do your units. So it was gallons per minute, and then it switched to minutes per gallon. So it says she changed the rate at which water flowed through the faucet. So write an equation that represents a relationship of W and T when it takes 3 minutes to fill the cooler with 1 gallon of water. Okay, so one equation could be let's see. T represents our so it'd be T equals 3 times W. So it takes 3 minutes per gallon of water. So 3 times the number of gallons of water tells me how much time it took. So another way to write this equation would be W W equals, what's the reciprocal of 3? So I could write T equals 3W or W equals 1/3 T. So they mean the same thing. I just used a reciprocal. So remember, here we were able to use a decimal, but that's because it stops after the 5. We can't use a decimal here because it's 0.3 repeating, and if we round that to just 0.3, then our answers for certain situations were going to be off. And sometimes that really makes a big difference. So you want to leave this as fraction form. So it says on number 5, was the cooler filling faster before or after she changed the rate of water flow? So was it faster before or after the change? Okay, so it was faster before, because before it only took 0.625 minutes to fill 1 gallon, whereas now it's taken 3 minutes to fill 1 gallon. So it took less than a minute before the change, and now it's taken 3 minutes. So it was filling faster before. Okay, 5.4, feeding shrimp. So it says at an aquarium, a shrimp is fed 1/5 of a gram of food for each feeding and is fed 3 times a day. So how much food does a shrimp get fed in 1 day? Okay, so we know that each feeding is 1/5 of a gram, and the shrimp is fed 3 times a day. So it would be 3 times 1/5, which will give me 3/5. So a shrimp is fed 3/5 of a gram each day. So you could write that as 3/5 or okay, so now it wants you to complete the table to figure out how many grams of food the shrimp is fed over a different number of days. So we've already determined that in 1 day, the shrimp is fed 3/5 of a gram or 0.6 grams. So for 7 days, how much food is that shrimp fed? Okay, 4.2 grams, good. And what about 30 days? 18 grams. So what is the constant of proportionality? Well, we know it's always beside the 1. So our constant of proportionality is 0.6. And that tells us, same thing as here, that the shrimp is fed 0.6 grams per day. Okay? So if we switch the columns in the table, what would be our new constant of proportionality? So before it was 0.6 or 3/5. So what would be the new constant proportionality? Okay, so it would be 5/3. So our new constant proportionality would be 5/3. So D represents the number of days and F represents the food in grams. So it wants us to write two equations. So D is days and F is the food in grams. Okay, so before we knew that F was 0.6 times D. So F equals 0.6 times D. And I used an O there, sorry. So F equals 0.6 times D. Or you, instead of 0.6, you could write 3/5. Or for our other equation, we know we have to switch our variables. So D equals, and we know we want our new number to be multiplied by F, a little bit further than I wanted it to be. So what would be our constant proportionality for this situation? Because here it was 3/5, so here it would just be 5. Not sure why it's not wanting me to write normal. So D equals 5/3 times F. So if a tank has 10 shrimp in it, how much food is added to the tank each day? We know that one shrimp needs 0.6 grams per day. So for 10 shrimp, we would just multiply 0.6 times 10, which gives us 6. So we know that 6 grams of food per day is added to the tank. So it says that if an aquarium manager has 300 grams of shrimp food for this tank of 10 shrimp, how many days will it last? So 10 shrimp require 6 grams of food a day, and he has 300 grams of shrimp food. So how many days will he be able to feed his shrimp? Okay, so you'd want to do 300 divided by 6, which will give you 50. So the aquarium manager can feed his shrimp for 50 days. Okay, so in the summary, it's just basically showing why you're able to rewrite that equation. So to get rid of 10 on this side, you would multiply by 1/10. And 10 times 1/10 is 1. So that just leaves 1 times t, which is the same thing as t. So that's why there's no number here beside t now. But because this equal sign means equal, it's just like a balance. So it means we have to keep the equation balanced. So if I multiply this side times 1/10, then I must also do that to the other side. So 10 times 1/10 is 1, and 1/10 times d is 1/10 times d. And that is still equal to t. So you can see that this equation, d equals 10 times t, is equivalent to the equation t equal to 1/10 d, because the reciprocal of 10 is 1/10, and our variables switched places.